Here we are at example 9 from our 5.27 notes. We're asked, what exactly is this whole end behavior thing? Well, between every single polynomial that we've just graphed, we ended up with one of two types of forms. We saw that we ended up with either a U shape of some kind or an S shaped. So for any polynomial, it's going to follow this form, whether it's a U shape or if it's an S shape. Now, if it's a U shape, that means that it has to have a degree that is even. So that would be like your x squared, your x to the 4th, x to the 8th. All of those will be a U shape. Whereas if it's an odd power, you will end up seeing that S shape, where we notice that they're going in opposite directions for the end behaviors. Now, when we're talking about just the leading coefficient, by the way, that happens for all polynomials. It's going to be one of these two final images, either a U or an S. So when we're talking about the leading coefficient, if it's positive, then the right side, in other words, you end up with either a U. We're not really saying if it's a U or S. We're just saying that the leading coefficient is positive. So in that, right now, we can be in either event over here, whether it's the U or the S. If the leading coefficient, though, is positive, well, we end up with a U either facing up or an S facing very much like this. And as a result of that, the right side of the graph, in other words, as we go outwards for x to the right side, our y values are always going to be rising. It doesn't matter if you're an S or a U. So that's always going to be rising. Now, if our leading coefficient, though, is negative, then we're going to either have a U going down or an S shape. Pretty much just take your S shape and flip him. And so a really good example of where we actually see these are from examples like example 6. We notice that we have that negative leading coefficient. It flipped that S. For example 5, we also see that negative leading coefficient. It flipped the U, so it's facing downwards. And as a result, it doesn't matter if you're a U or an S, because as you go to the left side of the graph, as you go to the right side of the graph, that is going to be falling down. Again, it doesn't matter if it's going to be an S or a U. Now, if you have a degree that is even, so you're pretty much in the U scenario, the U shape, then you have either a U going upwards or you have a U going downwards. In either event, though, the left side is going to be the exact same direction as the right. Meaning, whether you're going positive for your x values, we notice it rising, or if you're going negative for your x values, it's still rising. Likewise, even if you have a negative leading coefficient that flipped it. Whereas for an S, it's always going to be the opposite side. And the reason for that is if you have an even power, if you have an odd power, odd degree, you're either going to have an S doing something like this or an S doing something like that. It just depends on your leading coefficient. But as a result of that, notice they're going in two different directions for the end behaviors. So for example 9, the reason why we kind of want to know this information is because we don't necessarily always have to graph these things. In fact, I can look at all of these polynomials and instantly say what their end behaviors are. So for example, this first one, we really only care, for this polynomial, we really only care about this first piece. Because again, that's what really has our degree and our leading coefficient for that. This rest of this stuff isn't really going to help us out too much, at least in determining end behaviors. Now, because we are dealing with an x cubed that has a degree that's odd, we're going to have an S shape. So it's either going to be something like this or something like this. The leading coefficient determines whether this thing is pretty much like as a normal polynomial or if it's flipped. Well, because we have a positive 2, we know that we are ending up in this scenario, where it's a positive polynomial as it's graphed. For the right side, we see that it is rising up. So this rises. Whereas the left side, we see that it's falling down. For the next one, again, scanning for the degree here, we see that it's actually not the first term. Sometimes it isn't. Sometimes it could be in the middle, sometimes it's even at the end. But we see that our degree here is this piece. We also notice that our degree is odd. So we end up with an S shape doing something like this, or an S shape doing something like this. Again, this one represents if it's positive for the leading coefficient, and this one represents if it's negative for that leading coefficient. So the degree tells you whether it's an S or U. The leading coefficient tells you whether it's facing normally or if it's flipped. Now when we look at our leading coefficient, we see that he is -4. -4 happens to be negative. Well, then we're in this scenario. And as a result of that, as we go to the right side for our graph, in other words, as we go outwards to the right for our x values, we see that it is going down, or it's falling, for our y values. For the left side, as we are decreasing, or as we go to the left for our x values, we see that it's going upwards and rising. So this would be rises. On for the last one. Again, just scanning for the degree. That's not it. That's not it. It actually happens at the very, very end. So now we're seeing that we have an even degree here. Notice it's x to the 4th. And as a result, we're going to have a U shape doing something like this, or a U shape facing downwards. Again, the degree just tells you if it's a U or an S. The leading coefficient is the number right in front of that degree for the variable. In this case, we notice it is -1. So here's our positive, the polynomial facing up. Here's our negative, the polynomial facing down. The leading coefficient tells you if it's facing up or down. Well, because it's negative, we end up then in this scenario with the polynomial facing downwards. For the right side, as x goes towards infinity, in other words, as x is going out to the right, we see that our y values are going down. So this would be false. And we could even use our definition here. Even degrees, left side's always going to match the right. So as a result, we don't even really have to look at the small quick graph. We can just instantly know that this left side is also falling. So again, though, that is example 9 from our 5.2 set of notes. It's really kind of nice to see how the degrees play a role, whether they're even or odd, and whether the leading coefficient is positive or negative. You can also go back and maybe see the patterns from all of these previous ones. All right. But again, the nice little tidbits is that you don't actually have to graph these things to kind of see the end behaviors of them. And the end behaviors actually is pretty much like one of the first things that we start looking at when we study calculus. So you'll definitely see end behaviors again. They do not go away. Again, though, that is example 9 from our 5.2 set of notes.